So in addition to having and compound inequalities, we also have or compound inequalities. And an or compound inequality simply states that either one or the other needs to be true, and not necessarily both of them. So here we have something that's much more complex than what we started out with for our and inequalities. And this just makes us have to solve our inequality first. So if you recall, solving an inequality is very similar to solving an equation. We just go ahead and solve it like it is an equation, except we keep our inequality symbol. There's only one time where we have to change the inequality symbol, and we'll talk about that in another example, the next example. So in order to solve our first inequality, right, we want to make this as simple as possible. We want it to be x is less than or greater than blah, 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 whatever the number is. So in order to do that here, we need to subtract 3 from each side, and that gives us x is less than 4. Something much simpler, something that we don't have to necessarily think, okay, well, what other values are going to work? We have it in a much more straightforward form. In our other inequality, right, we'd need a few more steps than that. First, we would go ahead and add 1 to each side. So we have 2x is greater than 13. And then we would go ahead and divide both sides by 2. And you can either use a decimal or a mixed number here. This is actually a really nice decimal, so I would just use a decimal. X is greater than 6.5, or 6.5 if you prefer. So we have these two inequalities. I'm just going to write that a little lower. X is less than 4, or x is greater than 6.5. So again, just like the previous compound inequalities, we're going to put this on a number line so that we can graph it. We have our two boundary values at 4 and 6.5, or 6.5. And then we want to go ahead and graph this, right? So here in our pink, yet again, x is less than 4. So x is less than 4. We want to think about that. That's to the left of 4. So we're going to shade everything to the left of 4. And what kind of symbol are we going to have at 4? We're going to have parentheses that opens in the direction that we're shading. Then we have x is greater than 6.5. So greater than 6.5, that's everything to the right of 6.5. And again, we have a greater than, not a greater than or equal to, so we're going to have a parentheses opening in the direction of the shading. Now we need to look at this and ask, okay, well, when is this or that true? So basically, when we're dealing with an and compound, with an or compound inequality, we just need one of these situations to be true, this one or that one. So, well, one of them is true in this region below 4, and the other one is true in this region above 6.5. So we have our solutions in two separate regions. So we're going to go ahead and represent this using our interval notation, and we're really just going to represent each of these separate intervals just totally separately. So here, our lower boundary, it keeps on going and going and going, so that lower boundary is negative infinity, and the higher boundary here is 4, so negative infinity to 4. We always have a parenthesis next to negative infinity because we can't equal it, and next to our 4 we're going to have a parenthesis because that's what's in the graph. Then our upper region here, 6.5 to positive infinity, again, parenthesis, parenthesis. And because our solution is actually both of these sets put together, it's the combination of these sets, we're going to use something called a U for a union. This is not the same as the letter U on your keyboard. So when you're typing it into MyMathLab, in your little toolbox set in the upper right-hand corner, you have a U for this. So this would be interval notation. Now, an or inequality is like saying, for breakfast, I want pancakes or waffles, right? If they serve you pancakes, you'll be happy. If they serve you waffles, you'll be happy. But you don't need to have both of them, right? So like an and inequality is when you have to have both of them. Like I want bacon and eggs for breakfast. So if you only get bacon, you're not going to be happy. If you only get eggs, you're not going to be happy. In order to be happy, you have to have bacon and eggs. So that's a way that you want to think about or versus and. Or you're happy with just one of them, and you have to have both of them.